Problem 5 says if two altitude of a triangle congruent, then the triangle is isosceles. So if you have an altitude here and there, okay, if let's say A, B, C, and altitude means perpendicular line of to AC. So draw a perpendicular line from vertex B to AC. Let's call it E. And let's draw a perpendicular bisector to AB from vertex C. And let's call it CD. Now, if BE is congruent to CD, okay, then triangle ABC is isosceles triangle. So we started out with triangle ABC's isosceles triangle. In order for us to say that, so we can use hypothesis B is congruent to CD. So that's, in other words, BE is congruent to CD, right? In order for us to say this triangle is the same, we have to be able to say, we have to have AB is congruent to AC, right? Then in order for us to say AB is congruent to AC, then we have to prove that triangle AEB is congruent to ADC, so that AB and AC will be corresponding parts. So yeah, prove that. Prove these two triangles are congruent. Triangle AEB and ADC. If we could prove these, then we are set. Problem 6. Oh, that was actually problem 6. This is problem 7. Sorry. In isosceles triangle ABC, AC is segment AC is congruent to segment BC. Point M is the midpoint, so we have isosceles triangle. AC is ABC. AC is congruent to BC. Point M is the midpoint of AC, so let's say this is M, and point N is the midpoint of that. Point N is the midpoint of CB. Prove that CMN is isosceles triangle. Okay, so we have this. So in order for us to say that, so prove that triangle CMN is isosceles. That should come first on the top of the reverse list, and on the bottom we should have triangle ABC is isosceles. So in order for us to be able to say triangle CMN is congruent, we gotta prove that CM is congruent to CN. In order for us to be able to say that, we're gonna have to have two triangles, or maybe we don't have to. Why CM is congruent to CN, right? Well, again, M is the midpoint and N is the midpoint, and so that, and then we know that AC is congruent to AB, and we are M and N is the midpoint, so CM and CN should be equal, right? If these two are equal, then that's isosceles triangle. So write it out. Problem 8 is take a father problem, which is extension problem, so I'm not going to give you a hint. Problem 9, that's a standardized test prep. Triangle ABC at the right is an isosceles triangle with segment AB is congruent to segment AC. and angle ABC is congruent to ACB, and segment CD is the bisector of ACB, angle base ACB. And segment B is the bisector of angle ABC. Suppose you want to prove that segment EF is congruent to segment DF. So put the tick marks. For example, AB is congruent to AC, or angle ABC is congruent to angle ACB, and so on and so forth. Then you will probably start seeing something, and then you can choose either A, B, C, or D to complete the reverse list they have. Good luck.